Welcome back, aspiring chemist. Today we're going to discuss a very important and pressing topic in the subject of chemistry called acids and bases. And in today's video, we're going to discuss everything you need to know about acids and bases. So let's begin. So which one should I pick, acids or base? Well, since acids start with letter A and A occurs first in the alphabet, I'll pick acids. Now, acids are found all around us. They are found in fruits, in our blood, in our stomach, in carbohydrates, oils, and milks. But because of that, we don't generally describe or classify them acids. But as a science student, as a chemistry student, what is an acid? Well, an acid is a compound that when it dissociates in a solution, it releases a hydrogen, a positive hydrogen ion, or we can call it a proton, and its corresponding negative ions. Now, based on the mode of formation of acids, we have two types, which are the inorganic acids. These are also called mineral acids, and they are formed in a laboratory with, inorganic chemicals. And we have organic acids, and these are chemicals that occur naturally in the body, made by normal biochemical processes. So based on the amount of hydrogen ions or protons that are ionized in solution, we have two types of acids, which are strong acids and weak acids. Strong acids are generally inorganic acids, while weak acids are generally organic acids. And in a chemical equation, strong acids are represented by the straight forward moving arrow, while weak acids are represented by reversible arrows, meaning that the reaction could go forward or it could go backward. Also, there's something that we call a basicity of an acid. Now, this is defined as the number of protons or hydrogen ions that are replaceable in 1 mole of acid. Now, what am I saying? Let's take hydrochloric acid, for example. The hydrogen plus ion present means that it has the basicity of 1. Let's take ethane dioic acid, another example. It has 2 hydrogen plus, meaning it has the basicity of 2. And phosphoric acid, it has 3 hydrogen plus, meaning it has the basicity of 3. Guys, let's go on a little break. I also want to use this break to remind my viewers, if you haven't subscribed, to subscribe to my videos, because when you do, you'll be notified on my latest uploads. Because a topic in chemistry could be so long, so I don't want to just release an hour-long video. It'll be too much for my viewers. I've released the video so that they'll be able to understand the message that is being given to them, so that their knowledge in chemistry increases. Like, for example, I've just my latest release video was a video of fermentation. After knowing what fermentation is all about, we move to the practical, which is how to make vinegar at home. After making vinegar at home, you move to how to purify vinegar at home. After knowing how to purify it, you will move to the chemical and physical properties of purified vinegar, which is acetic acid. So it will be important for you to subscribe so that you're able to be notified on these serial videos, so that you don't miss any chemical knowledge or anything you need to know about chemistry. Okay, our short break is over. Let's get back to our video. Let's get back to our class, sorry. So, let's talk about the physical properties of acids. Now, these physical properties of acids are what majority of us use to identify acids, and I'm going to list them here. The first one is that acids in their dilute state are very sour. They taste sour like an unripe fruit. Let's say you're taking lemon, it tastes sour, or you're taking a ripe orange. That's how acids taste when they're in a dilute form. Also, acids turn blue litmus paper red. If you have a litmus paper at home, you can use them to touch maybe your oil or maybe an orange fruit or whatever. You will realize that litmus paper will turn the acid red. Another property is that concentrated acids, when they're in a concentrated form, they are corrosive. And the last property I will just say about acids is that they're very good electrolytes, meaning that they conduct electricity when they're in their aqueous form. And that's the physical properties. let's talk about the chemical properties of acids. This is basically like the most important part of, most interesting parts of acids. The first one is that acids react with metal generally to release salt and hydrogen. Like for example, you have hydrochloric acid reacting with, let me say, zinc metal. The product we have is zinc chloride and hydrogen gas. So acids react with metals above, which are high in the electrochemical series, to release hydrogen gas and a salt. Also, acids react with bases to form salt and water, and this is called a general neutralization reaction. That reaction is very popular in chemistry. It's important that you know it. And also, acids react with a trioxocarbonate or a hydrogen trioxocarbonate to release salt, water, and carbon dioxide gas. Now, those are the major properties of general acids, although that some other acids might have their own special properties, but this is the major chemical properties of acids. Well, to me, experiments are the most interesting part of chemistry, and I'm pretty sure you share that same viewpoint, and that's why our next subtopic is preparation of acids. I have some steps listed here, and I would like to discuss that with you. The first one is dissolving an acidic oxide in water or an anhydride in water, because when oxygen combines with non-metals like carbon, sulfur, nitrogen, they form oxides that dissolve in water to form acid. Like for example, oxygen can react with sulfur to create sulfur trioxide, and this sulfur trioxide will dissolve in water to create sulfuric acid. The next method I have here is a combination of the constituent elements. Now this is generally used from hydrogen halides. Like for example, hydrogen gas reacts with chlorine gas to form hydrogen chloride, and the hydrogen chloride dissolves in water, to form hydrochloric acid. The next method I have here is the displacement of a volatile acid by a non-volatile acid. For example, when you use an acid like sulfuric acid can react with our regular kitchen salt, table salt, to form hydrogen chloride, because sulfuric acid displaces the hydrochloric acid from its own salts, and then we form a new acid, which is hydrogen chloride. Now the last method, which I know is very easy for us to do at home, is what I call the backward reaction of neutralization. That neutralization I talked about earlier, when we turn the reaction backwards, we see that sodium chloride plus water plus energy will give us an acid and a base. Now this step has already been highlighted thoroughly in one of my other videos, so feel free to watch it so you can try this experiment at home. That wraps up the lesson for us today, and always remember to subscribe, like, and share my videos with your friends that you think may gain value from these videos, and I'll see you in the part 2 of what are acids and bases. So till next time.